Okay, let's keep going. So yeah. Mm-hmm. Okay. So where do you want this to be? Can we just preview this? Okay, whatever. Uh, let's keep going. Okay, shifting the coordinate system. That's something that yeah, this can be done. Okay, so you can change the axis by setting some kind of normalized linear equations as the xy values, and those normalized linear functions of x and y, those should be perpendicular to each other, if you know what I mean, you know. And okay, so that's it. That's what they want us to do. So let's go for in chapter exercise 2 then. So you don't want the answers. In chapter exercise 2, let's. So first, if the origin is shifted to a point negative 2 comma 3, axis remaining parallel to the, so just draw this thing. So this is 0 comma 0. This is 2 comma negative 2 comma 3 would be this, I think. And the origin is shifted to this point, axis remaining parallel to the original. So this would be the new coordinate axis. What will be the new coordinates of the point 1 comma negative 2? So basically you are saying using these using this direction as I had and using this direction as J had, basically tell what 1 comma negative 2 point is described by the point negative 2 comma 3, right? It's just, yeah, no big deal. So it's negative 2 comma 3 minus of that, sorry, it's only 1 comma negative 2. That's the point that we want to describe, minus the shift, which now we are shifted to this point, so it's negative 2 comma 3, and that will be 3 comma negative 5. Okay, so that's the answer. What's this? Question number 1, right? Okay, so let's go to the next question. Right, new setup. So I switched from infinite scrolling to these separate pages now. Okay, if the origin is shifted so that this equation has no first degree terms. Yeah, okay, I get it. Find the constant term on LHS in the new equation. No big deal. So you can write this thing as x minus 2 squared plus y plus 1 squared, I think, equal to 5. Oh, you just want in terms, you just want on LHS, right? So minus 5 minus 4 minus 1 equal to 0. Yeah, that will be minus 10 equal to 0. So minus 10 will be the constant term, right, in the LHS. So you just have to shift to the point 2 comma negative 1, and that will be it. So minus 10 is our answer. This is question number 2, I think. Okay, next question. If the axis be rotated anti-clockwise to an angle 45 degree, then what does the equation 4xy minus 3x squared equal to a squared become? Axis be rotated anti-clockwise to angle 45 degree. So just rotate them, don't shift them. What does this equation become? Okay. So let's think of a point. Okay, whatever. Just you wanna shift this 45 degree like this, right? So now let's say that this is our capital X axis and this is our capital Y axis. Then for some point, you know, this was your X and Y coordinate, but now this will be your Y coordinate and this will be your X coordinate. Yeah, right. What is the equation of this line? It's just Y equal to X, right? And that means Y minus, or I should say like X minus Y upon square root 2 equal to 0, right? And what is the perpendicular distance from this line? the sine perpendicular distance. Yeah, that's exactly this thing. Similarly, the sine perpendicular distance from this line, that will be x plus y upon square root 2, right? So you can define capital X to be this guy and capital Y to be this guy. So just to check if these like X and Y are positive, where X is bigger than Y, but if X is bigger than Y, then this thing will be negative, I think, right? So capital Y must be, wait, this should be capital Y because the distance from the capital X axis, that's capital Y. This is capital X. So then it's negative. So it should in fact be Y minus X. Okay, that's very nice. Now what? So we shifted this, then this equation becomes, so you can figure out what X and Y should be. So you can do a similar backward, okay, or just solve it proper. Yeah. So y minus x equal to square root 2 capital Y. Y plus x equal to square root 2 capital X. Add these up, it should just be 2y equal to 2 square root, no, 2y equal to square root 2 of x plus y. So y is capital X plus capital Y upon square root 2. And x will, when you subtract this is going to be capital X minus capital Y upon square root 2 once again. Okay, so now we know what capital X capital Y is, and we just want this equation in terms of capital X capital Y. And it shouldn't be that hard. So this is 4xy, and now we'll put these xy values as these things into that, and that will be x squared minus y squared upon 2 minus 3x squared. So minus 3 times x squared, that's just x minus y squared upon 2 equal to a squared. Cool. So this will be 4x squared minus 4y squared minus 3 times of this guy, so like minus 3x squared minus 3y squared plus 6xy. This should be equal to a squared. That's what this is. So the equation is negative 6. Okay, this is weird. Why is this negative over there? I don't know. It's just x squared minus 7y squared. I know it's a hyperbola and stuff, but it's still weird. Yeah, hyperbolas are pretty weird actually. Okay, so this is our solution. Next, equation of a line is this guy. If the coordinate axis be rotated by angle theta, then the equation becomes this thing. Oh, okay. Value of a squared plus b squared is a squared plus b squared. The coordinate axes are rotated by angle theta. So it's like the general case for doing this. Maybe we should deal with vectors, right? Think about it. If you are rotating the coordinate axis, and with respect to the coordinate axis point of view, you are rotating the actual plane, like all of the points on the plane, by theta clockwise. Isn't that how it is, right? So if you had x comma y, which was satisfying this equation, 2x plus 3y equal to 6, then now your new x comma y, let's just say x naught comma y naught. If this was your original point that was satisfying this equation, then after you rotate by theta clockwise, this will turn out to be what? So it's like write it as an imaginary, okay, as a complex. Oh no, you don't know about complex numbers. Why? I should not be using complex numbers here. We are doing straight lines. Yes. So okay, let's do this thing. You rotate it by angle theta like this. So now this will be y equal to tan theta x, and this thing will be y equal to negative cot theta x. You got the thing. Or you can say it's like cosine theta y equal to sine theta x. So write this as or maybe you can write it in the opposite way. So the whole thing is that cosine theta y minus sine theta x upon square root of cosine square theta plus sine square theta, that's just one. This is this sine length, and then this sine length, so this we'll call that as capital Y. Okay, wait. But you don't want in terms, oh yeah, this is gonna get very bad. You just want to express small x and small y in terms of capital X and capital Y. So then your theta is different. So like you're changing it clockwise. Okay, I understand what's happening. Then, okay, so in that case, let's not use all of this. Just delete everything. This angle is theta, right? This is our x-axis. This is our capital Y-axis, right? So this thing, this line will be capital Y equal to negative capital X. Sorry, equal to negative tan theta times capital X, right? And this line will be capital Y equal to cot theta capital X, right? So now you just need to write small x and small y in terms of capital X and capital Y. So what's the distance from this line, like this? This is so complicated. So I think bigger y corresponds to a positive distance, I think. So you can say it's like cosine theta capital Y plus sine theta capital X. That's what this will be. That is our small x, and similarly small y is wait, no, this is not small x, it's small y already. Distance from distance from what was I gonna do? From small x axis, that's small y. Similarly, small x, that will be positive when your capital X is positive, I think, and your y is small, like this. Yes. So this will just be cosine theta capital X minus sine theta capital Y. Cool, you got it. And now just put these as these values into whatever equation we have. This is so complicated. Right. Okay, fine. Just put it in there. So 2x, there will be 2 times of all of this, and plus 3y. Okay. Wow, this is weird. So it's going to be 3 cosine theta minus 2 sine theta times y plus 3 sine theta plus 2 cosine theta times x. Yeah, that's equal to 6. Okay. And just divide this by 6 as well. Now it's equal to 1. Value of a square plus b square. So this guy square plus that guy square. That's just 1 upon 36 into 3 cosine 9 cosine square plus 9 sine square is 9. And then similarly 4. And then minus 12 cosine theta sine theta plus 12 cosine theta sine theta. That just cancels. Okay. Seriously, we need to think of a better way to solve this. Yeah. What better way do we have than just doing this? Maybe we can use some kind of vector analysis. So, okay, we'll do that in the next page. So what we will be trying to do is just shift this to any point with any angle like theta, and this is our alpha comma beta point. This is 0 comma 0. This is, yeah, we just want to shift to any point and figure out what capital X, capital Y are in terms of small x, small y, and what small x, small y are in terms of capital X, capital Y. So it's basically a linear transformation. I should not be talking about matrices and stuff, but that's just how it is. The best way to represent this is as a matrix. Okay, okay. So you can think of it as two, yeah, like two translations. Yes. So first what we'll do is just consider a point x comma y, right? And then figure out what this point is in terms of, let's call this thing I hat, call this thing j hat. So what is this vector? That's just x minus alpha I hat plus y minus beta j hat. And now we'll say this whole thing is capital I hat and this thing is capital J hat. Okay, so that means capital I hat is cosine I sine. Okay, don't use complex numbers for this. Whoa, that's not supposed to happen. What is it's going to be cosine theta I hat plus sine theta j hat and some stuff like that. And then this guy, we just want to express it like so. It's just a linear transformation after all. I get it. I understand how this should be happening. It's just that it's kind of, yeah. Okay, j hat is just negative sine theta I hat plus cosine theta j hat, like that. Okay, and then what? Similarly, you can, I guess, do for small I hat. So like small I hat, that will be cosine theta capital I hat minus sine theta capital J hat. And why is this so complicated? Small j hat, which is really should be like this, and this angle is also theta, by the way. That will be cosine theta j hat. So what's this? Sine theta I hat plus cosine theta j hat. Okay, now we are in a good position to answer stuff. So now you know how to express this. I just want to write it as a matrix so badly, right? But we'll deal with it just like that. Okay, and then what? Now you know how to express these in terms of I and j. What do you do after that? You want to express this small x comma small y point in terms of capital I, capital J. So this thing, this vector can be written as x minus alpha into small I, which is this thing. So cosine theta I hat minus sine theta j hat plus y minus beta into sine theta. Is this a good idea or a really bad one? I don't know. Well, I really want to express this as a matrix, huh? Okay, whatever, just express this as a matrix. This will be cosine theta, say C. This will be S minus S and C, and then the vector that we're talking about is just x minus alpha, x minus beta. That's what this thing really is. Yes, and this will be our, I don't know, capital X comma capital Y, right, for this point. Cool. So this equation, this is a good transformation. And yeah, I hope this will work. So I'll call this a rotation matrix. I mean, that's what they call it really. But okay, how do I remember this though? I don't know. I don't know how to remember this. You just have to look back to it every single time then. Okay, that's done. Let's go to the next question. Where was I? Oh, fourth. Let's go to the fifth question. If the axes are shifted to the point, this thing, so alpha comma beta is -2 comma -3, and then they are rotated through an angle of 45 degree in the anti-clockwise sense, what does this equation become? Oh, so once again you can express what capital X and capital Y are in terms of small x and small y, but we also want to be able to do the opposite thing. So you can say small x comma small y, that thing is just capital X, small x is, oh come on, think of it, it's just capital X plus no, but capital X is a different thing altogether. So you have capital X, capital Y. First you would need to convert that into the coordinates using these coordinate axes, I mean, okay, those directions, but this point. Okay, so basically you're writing an inverse of this thing. Wow, this is so complicated. Right, so there was some point capital X comma capital Y, and you just want to express that point in our original Cartesian system. How would we do that? First we would have these axes. Think about these axes. So you are changing capital I hat to small I hat and stuff. So we will multiply by this matrix, cosine, sine, minus sine, cosine times capital X, capital Y. Right, that will give us what this is. This will be just small x minus alpha and small y minus beta. So you can use this equation as well, I think. Oh yeah, it's basically just applying the inverse of this matrix on both. I mean, do you people actually understand what matrices are at this point? I don't know. Maybe you guys are from the newer batch, so you might not understand this. But if you ever learn matrices, just remember that they are incredibly useful in these rotation and stuff. So yeah, just keep that in mind. So you got this matrix equation, right? And then we can just add alpha beta vector on both sides to get this. So this plus alpha beta, that is our xy. So I will just be using this equation a lot. I think I've never used this once in my life, but let's try this time. Okay, so now what do we have? For the fifth question, you have alpha beta as this vector as -2 and -3, and then they are rotated through an angle of 45 degrees. So theta is 45 degree. What was this? Yeah, it was cosine, negative sine, and then sine, cosine. Yes, this guy will be, so it's 45 degree, right? So it's going to be 1 upon square root 2. Theta is positive 1 upon, theta is positive 45 degree. So it should be 1 upon square root 2 minus 1 upon square root 2, 1 upon square root 2, 1 upon square root 2. which is basically just 1 upon square root 2 into 1 minus 1, 1 and 1. Okay, so this thing times our capital X, capital Y. Hopefully this will make sense. Okay, this will be 1 by square root 2 times, let's look at this, capital X times that, so plus alpha beta, which is negative 2, negative 3. This guy will be our small x, small y. Alright, cool. Yeah, this looks right. So now what? You got what small x, small y are in terms of capital X, capital Y. Should you just put that in that equation and do all the algebra? Maybe not. First, let's try to simplify that equation. So 2x squared plus 4xy minus 5y squared plus 20x. What is this? Just what is this? No, it's very bad. Not easily doable. Maybe you just have to put small x, small y, these things, and just try to do this thing. Maybe negative 2, negative 3 are somehow related to this. Isn't there anything that we can do? We want 4xy, right? And then you got that y squared over there. It's very different than what I was expecting. It's got 22, so you need 11y, something like that. No, it just doesn't make sense. Okay, maybe we could try doing step by step, like first transformed by shifting to negative 2 comma negative 3. Then you can just put x as, instead of x you just put x minus 2 and x minus 3, because x plus negative 2 and sorry, y plus negative 3, and we'll see what that gives out, and then we'll try to rotate it. Okay, maybe that's a better way of doing this. Really, I've never actually used this concept a lot, but it turns out to be there in a lot of topics actually. It's useful, it's not that very complicated most of the time. Okay, so instead of x you're going to put what, x minus 2 plus 4. Not sure if this idea is even good. xy is 5y squared. Minus 22y minus 24, right? What does this turn out to be? It just turns out to be 2 times of x minus 4x plus 4, which is 2x squared minus 8x plus 8. This will be 4 times of xy. What is xy minus 3x minus 2y plus 6. This will be 4xy minus 12x minus 8y plus 24. This will be negative 5y squared minus 6y times negative 5, so it's plus 30y. 9 times negative 5, which is negative 45. Wow, this is just bad. And now you just have to add all of this up. Seriously. So you only got one x squared term. Yeah, only one y square term. See, minus 8x minus 12x, that's minus 20x. But this plus 20x, so it just cancels. Okay. Minus 8y, 30y, minus 22y. Okay, this also cancels. Nice, really nice. And then 4xy, that's still there. You can't change that. Now all the constants. So minus 40 minus 45, that's minus 85. This plus that, that's 90. 90 minus 85, that is 5. So 5 plus 3 is, sorry, why? What happened? Okay. What was I doing? It's 85. This thing is 90. So it's 5. 5 plus 8 is 13. Minus 24 plus 13, that's minus 11. So this is the equation after shifting. And now we want to rotate this. Okay. So now you have to bring in that matrix. So what was it once again? Cosine, negative sign, sine, cosine, I think. That's what it was. Yes, that times capital X, capital Y. That is our small x, small y. So in this case, cosine theta is just 1 over square root 2 and all that stuff. So it's just 1 upon square root 2, 1 minus 1, 1, 1. So x is capital X minus capital Y upon square root 2. Y is capital X plus capital Y upon square root 2. Okay, once you got that, just put that into this. It's getting very, very long. Okay, 2x squared. Square this, square this. 2x squared is just x minus y squared. It's x squared minus 2xy plus y squared. Then minus 5y squared. So it's 5y squared. Okay. Maybe we could change this a little bit. So 2 times 4 is 8. 8 can be written as 4 and 2 won't work. No, it can't be written as something that works. You just have to do it manually. Yes. Well, at least we can take a y common from this. Like y times 4x minus 5y. So this will be like x plus y upon square root 2 times 4x minus 5y. So 4x minus 5x is just minus x. Then minus 4y minus 5y, that's minus 9y, that upon square root 2. I think that's better. It's going to be negative. And what is this, like negative x squared plus 10xy plus 9y squared, all of that upon 2 minus 11 equal to 0. So this is the equation that we get. I just need to simplify this. Why is this so big? Okay, so that times 2. This will be 2x squared plus 2y squared minus 4xy minus x squared minus 9y squared minus 10xy minus 22 equal to 0. Okay. I need more space for this. So it's x squared minus 7y squared minus 14xy equal to 22. There you go. That's the equation. Okay. Hopefully this works. Next. Equation of circle having radius r and center at origin is this thing. What will be the area of the circle having equation? Hey, what is this? Oh, okay, fine. Yeah, you don't need that hint. I mean, you already made me do a lot of bad things with this question. What does this hint now do anyway? Right, so it's just x minus 1. Hey, what question was this? I didn't mark that. It's 5th question. Right. and I also didn't mark this. Huh. Okay, whatever, next. And this will be the question number 6. Okay, equation of circle having radius r and center at origin is this thing. What will the area of the circle having this as the equation? So it's just x minus 1 squared plus y minus 2 squared, and that thing equal to 4 plus 4 plus 1, which is 9. So it's 3. The radius is 3. Oh, we want the area, it's pi r squared. So it's 9 pi. Question number 7. To what point the origin must be shifted to eliminate x and y terms in this equation? Once again, similar kind of thing. Oh, there's this xy term that I hate. It's 2x squared plus 3xy minus 2y squared. So there's everything in there, just everything. Okay. Eliminate the x and y in the equation. Come on, think of something. You just want the x and y terms to be eliminated, nothing more, right? Oh, that's a different thing. Let me think of it, man. You could probably be rotating. No, that's not what. So the only way is actually to put x as something as x as x minus alpha, and then put y as y minus alpha. Sorry, y minus beta, and we'll see what we get. So 2 times of x squared, that's going to be 2 times of 2x squared minus 4 alpha x alpha squared, and then minus 2y squared. So minus 2y squared plus 4 beta y minus beta squared, and then 3xy xy, that will now be xy minus beta x minus alpha y, xy minus plus alpha beta, and what, like plus 3 times that, so 3xy minus 3 beta x minus 3 alpha y plus alpha beta. Okay, and then what, minus 7x plus y, so minus 7x plus 7 alpha plus y, which is plus y minus beta plus 3 equal to 0. So all the linear terms, this guy, this works, this it's minus, this thing, and this thing, and this. So for x it will be negative 4 alpha, negative 3 beta, negative 7. This guy must be equal to 0. For y, it's 4 beta minus 3 alpha plus 1 equal to 0. Okay, got it. This thing just turns out to be 4 alpha plus 3 beta plus 7 equal to 0. So how do you solve this? I think if you just guess alpha equal to negative 1, beta equal to negative 1, putting it like that, just have negative 4 plus 3. Yes, that's negative 1. Cool. So that works. Both being negative 1 work. So just have to shift it to a point negative 1 comma negative 1. Yes. This is our answer. Question number 8. Okay, the equation of the line, this line and this line can be written as this and that. Be shifting the origin to a suitable what? Be shifting grammar. Origin to a suitable point, coordinates of this point. Okay, so this can be written as these equations if you shift the origin to a suitable point. Coordinates of this point are. Okay. So x plus y minus 1 became this. Let's do this thing. X minus alpha This line is pretty much the same thing as x plus y equal to 0, right? So what that means is like alpha plus beta plus 1, that thing should be equal to 0. Okay, and then this guy, x minus alpha minus y plus beta minus 1 equal to 0. And this is x minus y equal to 0. Once again, the constants are all just const, so beta minus alpha equal to 1. Or we can just say beta is 1 plus alpha. Putting this thing into that, you just have 2 into 1 plus alpha is 0. Well, that means beta is 0, alpha is negative 1. So our point is negative 1 comma 0. There we go. Question number 9. If the origin is shifted to this point, this equation becomes okay. Well, then this y, this will be y plus of minus 2, I think, because wait a second. To this point, then how does that make sense? Oh no, I think I'm messing up something. Oh, this is bad. This is really bad. I shouldn't have done it like this. If you have this x comma y point and you are shifting to alpha plus beta, then on these coordinates, the new x comma y, those will be x minus alpha and x minus beta, yes. But, oh, okay. This will be like equal to capital X, capital Y. So, in fact, you are putting small x as beta. Sorry, this will be equal to capital X. This will be equal to, okay. So you're putting small x as x minus alpha. No, what am I doing? You're putting small x as capital X plus alpha and small y as capital Y plus beta by these equations essentially. So that means you have to put these values in that equation. So what I did was wrong. Man, these are really confusing. What was I doing once again? Where did it go? All right, question number 8. So now it would be alpha plus beta equal to 1 and alpha minus beta equal to 1 as well. That means alpha is 1, beta is 0. So 1 comma 0, that's where you shift this. All right, now that makes sense. Okay, 9. If the origin is shifted to this point, this equation becomes, once again, instead of y, we have to put y minus 2, not y plus 2. So this will be y minus 2 squared minus 4 into x. Instead of x, you just put x plus 1, right? Plus 4 times of y minus 2 plus 8 equal to 0. Yes. And that just becomes y squared minus 4y plus 4 minus 4x minus 4 cancels, plus 4y minus 8 plus 8, oh that's nice, cancels, equal to 0. So y squared, oh wow, that cancels as well. Huh. What do you know? Y squared with 4x. That's what this equation is. By what angle, oh we don't want that. By what angle coordinate axis must be rotated about the origin in order to eliminate xy from this equation? Okay. So you know you will just be putting x as, okay, xy as cosine minus sine. I think, yeah. Cosine minus, what was this? What's this? Yes, cosine minus sine, sine cosine. times capital X capital Y, right? You'll be putting small x small y as these things, and you want, I mean, you just hope that xy terms will get eliminated, though that is kind of yeah. So let's see what we get. Let's start. Small okay, x squared plus y squared, and that will be cosine. Small x is just cosine x plus sine y, that guy's square. And then similarly this thing will be plus negative sine x plus cosine y square, which will be, so cosine squared x squared plus sine squared x, which is x squared, plus y squared, and everything else, well, that cancels. And then for xy, oh, okay, that's weird. It's gonna be cosine all right, this is equal to 1. That should be happening. So this guy, this will be sine cosine x squared negative sine squared xy negative cosine squared xy plus sine cosine y squared. Only way for this to become 0 is this complete thing, is if you have, wait, that cannot be, because these are like square. How can that even be? Ouch. Oh, what am I missing? Cosine x plus sine, oh, that explains this. Sorry. So what was I doing once again? Right. Minus sine x plus cosine y. This should be minus sine x plus cosine y is the y value. That is better. It's much better. Okay, what will this turn out to be? Negative sine cosine x squared plus sine cosine y squared plus cosine squared. Oh, what am I? Yes, cosine squared xy minus sine squared of x. So the only way for this xy term to be gone is if you have cosine squared equal to sine squared. Right. Oh, that's actually really nice. So next time I just get x squared plus y squared, I will know that rotating it, you just get x squared back, x squared plus y squared back, which shouldn't be that surprising, because x squared plus y squared, it's just the distance from the origin. You're just rotating the thing. You're not changing its distance, right, from the origin. So your x squared plus y squared will remain the same. And I mean, it's not like, but yeah, it just turns out to be the same as x squared plus y squared as a function. Yeah, weird. That's how it is. So cool. You should have sine squared equal to cosine squared. That means tan squared equal to 1. Alpha is n pi plus minus 4. What's this question number 10, I think? So your theta, whatever angle is, it's just n pi plus minus pi by 4. This is our solution. Question number 11. Oh, there's no question number 11. Okay, cool. Oh, so they put plus minus pi. I mean, of course, because n pi, let's just overkill. You only need 2 values because slope, right? Yeah. It should represent a slope, basically, I think. But I mean, okay, it can be all the way till 360 degrees actually. But if you're talking about axis as lines and not as rays, then yeah, it's just in 0 to pi or negative pi by 2 to pi by 2. So this works. 10th is correct. 9th y squared equal to 4x, that's correct. 8th 1 comma 0, that's nice. I got negative 1 comma negative. Oh yeah, I put this substitution over there, that it's x minus alpha and x minus beta. In reality, it should be x plus alpha plus beta. Then this would be plus 1 and plus 1. Yes. So it went wrong, even though I did it correctly. The method was kind of incorrect. Okay, sixth, it should be 9 pi. Yes, that's right. Fifth, x squared minus 14x minus 7x. Yes. Wow, I didn't expect all of this to turn out to be correct. Like, but it is. That's not a question. 13 upon 36, that's correct. This was question number 4. And two a squared. Because this 2, you multiplied by that 2. So it should be 2a squared. It's such a slight error that went, just made it wrong. But I have to be honest, I'm gonna get it wrong. Need 10, that's correct. And yes, that's correct. So that's it. I'll see you guys in the next video.